short or long, depending on how it goes. So what we want to do simply is reduce the number of code we write using macros, right? Can someone, I prefer someone who is relatively new, can, what's her name? Can Priscilla, I don't know how new, okay, let me see, she might not really know. Let me do, sure. Cheryl, can you tell us what macros are about, if you know? I don't know if Cheryl can hear me. Hey guys, I just want to confirm that you can hear me. Can anyone else hear me? Let me know that. Okay, cool. So who wants to volunteer? Who wants to tell us what macros are about? Maro, yeah, that's good. I'm sure you would know though, but yeah, please help us out.
Okay. Hi guys. Good evening.
Mhm.
Um, I, I think since nobody, so macros are ways of generating code using code. So it's like meta programming. So you can think about it as, when you write in Rust, right, the compiler has to compile it into assembly language, which is expanding it into like new to a different language, right? So that's like code generation, but from the compiler. With macros, what you're doing is that at compile time, you're using a small amount of Rust code to generate another set of Rust code. So it's like templating in a sense.
That's good. Thank you so much for that. So in essence, that's what macros are about, right? And for our own use case, we are not going to be writing our macros ourselves, right? But we are going to say use some macros that have been written for us. We're going to look at how valuable those macros are for our, for our workflow and experience as developers, right? Um, I'm not sharing yet, but I will share my screen now. Entire screen. Yeah, start sharing my screen. So now this is a macros folder, that I downloaded from the course we are following. Right? The macros have already been written for us, but our job will just be to make use of them. Right? So we have two macros. We have the call macro and the runtime macro, right? And we are going to use it to replace some codes that do calling for us and some of our runtime code. We are going to use those macros to replace it. And this is going to, this is going to help us avoid writing some codes, or it's going to help us delete some codes from our code base. Now, because our code base is small, you might not easily see the benefits of this. Yeah, Cheryl.
Oh, sorry, that was a mistake.
Okay. You might not easily see the benefit of this, right? Since our code base is small. But imagine working with the Polkadot SDK code base, right, which is very large. Instead of when you want to say add a new, say, palettes to your Polkadot SDK implementation, right? Your life will be much easier if you are using a macro that has already been created by the Polkadot developer team, right, for specific use cases. right? It makes your life easier. You don't have to write. It reduces the amount of code you have to write. Then secondly, it even guarantees that the system works as expected, right? Because they've written the macros for you, right? Remember what we said, macros are codes that write other codes, right? So when you plug the macro into like a template code, it's like it takes in that template and it brings out, during compile time, it produces the expected code that we need, right? That we generated from that template. Okay, and so by using macros, we ensure that the system, we ensure that the modular system works as expected, right? So I have a palette. I want to add a vesting palette to it. My vesting palette has a function, a transfer function, but that transfer function is supposed to implement, say, a call, a dispatch. Is supposed to dispatch a call to the runtime, right? Now, I can decide to write this code myself, but how am I sure I will not introduce bugs when I write it myself? So instead of writing it myself, why don't I use the macro provided by the Polkadot SDK, right? And so that at compile time, the Rust compiler just expands that macro, and it gives me the code embedded in it, right? And so I avoid errors, I save time, and my life is better for it. So this is the concept. This is the value that macros provide. And so just diving in, I'm going to start with, so first of all, just know that this macros, what would I say, the implementation of the macro, we had to import it here, we had to add it here, right? And then the next step would be to import the macro, add it to our cargo.toml as a dependency, right? Macros. So we just need to follow the paths and so we've added macro as a dependency. Let's build. Okay, so we have a macro in our. So move on to the next step. All right, so now we just want to basically use the macros that we have. So we are going to, first of all, we need to modify our function, right? Because so we want to use the call macro. We have two macros there, right? The call macro and the runtime macro. Let me close some folders. You have the call macro. So for the call macro, we want to use it to kind of automatically create our code that dispatches a call, right, from our balance palettes, essentially. So that means we need to modify the function, right, so that we can be precise in our use of the macro. What function do we need to modify? So we need to move our transfer function into its own implementation. All right. So where's the transfer function? We are going to have a new implementation here.
Sorry, boss. We're not seeing
Sorry, am I the only one? I can't see your screen again.
Okay. Stop sharing.
Yes.
But did you see when I added the macro to the cargo.toml file?
No, sir.
Okay, wow.
Cargo to yes. We
You
saw
saw
that.
that. Okay. So how come it stop sharing? Okay, so we want to create a separate implementation for the transfer function only, right? So that we can add our macro on it.
It stopped sharing your screen again.
So it's probably my network because I didn't stop sharing intentionally.
Yeah, maybe an network or something.
Maybe you can restart
Oh.
it, reshare it again. Like stop and
Okay. Okay, like just reshare my screen again, right?
Yes.
You can restart your network.
We can see it now.
Okay.
Yeah, you can see us.
Stop by itself. Okay. So basically what I'm doing is I'm doing an implementation similar to what we did here. I want to do it for, initially this implementation was inside this our implementation for our palette, we add this transfer function in it. Right. But now I want to separate the transfer function because I want to add the macro to it separately. Right, because our macro, what it does, it takes in the function we pass to it, right? And it kind of expands it for us. So because the functions we pass to it, so because we don't want to pass these functions to it, we are going to separate them. So what I'm doing now, I already have this end here. Okay, so to add a macro, this is how you add your macro, your call macro, using this syntax. Okay. So we also want to delete something called the enum call function. Right, this is something our macro is supposed to help us produce automatically. And also, there is now something interesting about macros, right? Now, because we are passing in this function automatically, and you can see this function is in lowercase, the function is going to produce at compile time is also going to whatever attribute of that function, if it has to use this transfer keyword, it's also going to be in lowercase. So this means we have to make some adjustments in our main.rs file, right, to ensure that since everything works as expected. What do we want to do? We want to change our call to the balances palette. So we want to change it from uppercase transfer to lowercase transfer. So every instance of that, we just change. All right. So we'll compile again to ensure everything works fine. Okay, we have an interesting error. Could not find call imbalances. Okay, why is that? Did I not add my macro correctly? My first call. In case you notice any error, just let me know. Dispatch. Okay, I think I have to delete my existing implementation of dispatch too. Okay, so this is part of the code that macro is supposed to help us generate. I will still have an error. Method not found in palette runtime dispatch. Okay. Sorry guys, give me a minute, please. I want to attend something. All right, so let's know what's going on. Call OP. Consider importing this anon. Use create proof of existence call. I shouldn't have to import any anon. Or does this mean my macro is not being detected? Let's see. Macros is here, cargo.toml is here. I'm going into this. So I'm not making any error with my path, right?
No. In your macros folder, is there lib.rs?
Yeah, there is.
In the SRC, there's lib. Let's see. The parts are correct.
Okay.
Macros. So I don't know why.
Proof of existence palette, is it being imported into the main.rs?
Need to import it into the main.rs.
Yeah, the proof of existence palette is here. So what I will just do now, I'll just copy the code from that raw state machine book and try it and see if it will work. So I'll know if there's a fault from somewhere else. So this is the balances palette. This is the main.rs.
You have to copy the solution, not the template.
Thank you.
Yeah.
That's balances. So we have the main.rs. Okay, let's try that again and see. So we know where our problem is from. Okay, so there is no issue with this. So where was the fault from? So first, this was what we're trying to achieve, right? We wanted to, so if I do a command Z, we basically wanted to ensure that our transfer function is separate from the other functions, right? And use this macro on it so that some calls that the transfer function is supposed to dispatch are done automatically, right? And in our main.rs, we wanted to change the occurrences of transfer to lowercase. So where are those things here? I have to search transfer. Okay, it's lowercase, which is exactly what they did. Well, they have 2 occurrences of transfer, but I believe I had 4 occurrences of transfer when I checked mine. Then so should we just do a bit of track back a bit? Maybe we can detect where the error came from the last time. Okay, so we have log 3, log 4. So you can see that they have 4 occurrences of transfer, but I had 2. Should fail. Support extrinsic. Support extrinsic. I think this code was okay. It's because of the way I think it's because of the way we wrote ours. You know, we did it as a bit differently. We added some extra functions. How we did ours. But yeah, I'm just going to paste this back. I don't know if I want to start tinkering with it now. So, but do we get the basic idea of what we are trying to do? Like, so if you notice, we've had to delete a number of codes, right? So if you were writing from scratch, right, this balances palette, for example, if you're writing it from scratch, what that means is that all those dispatch right. Okay. So what that means is that you won't have to write this, right? And also the enum stuff that we wrote the other time, you won't have to write it. So, and you not having to write this means you are going to avoid some possible errors that you might encounter or bugs that you might introduce if you wrote it yourself. So that's just the benefit of using macros. Better developer experience. So let's try this again for another palette. Hopefully we'll get it right this time. So let's say we want to do the same thing for our proof of existence palette. Right. And so we want to add the call macro to it also. So what are we going to do? So first we want to separate some of the functions because we need to apply the macro to specific functions, specific relevant functions. So we're going to implement these functions. Implement palette for these functions. So we already have that it. So similar to what we did the other time, we add the macro here. Somehow I feel the problem I had the last time was probably from my spelling of macros. So also like we did the other time, right? We delete our, call, our dispatch implementation, you don't need them. And also we are going to change because of the way these functions are named, right? They are not using camel case, they're using snake case. So we have to change their occurrences in the main.rs file. Have to change wherever we see create claim, we change it to snake case. We also change the other function, revoke claim. Revoke. Okay. Yeah, definitely. My problem was from the way I spelled macros the last time. Okay, so it's the same idea, right? Just how do you write less code, assure code uniformity, ensure code uniformity, and improve developer experience. That's the idea. And by the way, this is the Polkadot SDK uses this a lot, right? And I think it's one of the things that makes it quite abstract for people, right? And abstraction can sometimes make you feel like you don't really understand what you are doing. Well, this is just to help us have an idea, have a sense of what's going on under the hood, right? So what we did in the previous class was implement this by hand, but now we are replacing it with macros. So one exercise we can do quickly. I don't know if this is beneficial for us because do I really know what is going on under the hood? Can I explain it? But it's to see, the generated code, like what will be generated at compile time, right, by our macros. So in order to do this, you use what is called cargo expand. I've already installed it earlier. I'll just go through the motions again. Oh, I thought I installed it. Why is it? Okay, I'm guessing. So we'll just have to put it into a file called out.rs. Yeah, there's our file. Okay. So everything has been. So let's see if we can see that's our enum call. So do you notice that this is the code that we deleted? And did anyone notice that? The code we deleted from our file previously. This is the code for this is for the balances palette, right? And you will see the same code for our proof of existence palettes, right? But for our support palettes, we don't have that code, right? Because you can see there's no enum call stuff here because it was not implemented for it, right? And we also didn't include the macro for it. So does that make sense? I would like Rama to explain what I just explained, so I'll be sure that people are following. To explain what I just explained, can you tell me what you understand by what we read from the exercise we just did? Hi, Pupola Rama, can you hear me? Can you guys hear me?
Oh, sorry. I don't know that you called me. You said I should do what?
So can you tell me what you understand by the short exercise that we just did? And all the things I just showed.
Okay.
You said you didn't hear me though. Are you sure you were concentrating?
Yes, but I don't know that you called my name. Like I thought you were talking to someone.
Okay.
Okay, we tried the macro. Let me say, whereby we deleted our enums and dispatch function, the one we had earlier. So it now generated the out.rs with expand. So initially I wanted to ask a question regarding the out.rs. So
Okay.
inside the out.rs, the code you deleted was it appears inside. And basically I don't understand why we generated that particular code with expand. You install the expand.
Yeah.
So so that's what you now use to generate the out.rs. So I was following. It's just that I'm not getting it deeply.
Yeah. So that out.rs code we generated is just a demonstration for me to show you what would happen at compile time, right? So we deleted some codes. I used macros in place of them, right? So in our original files, we don't have those codes there, but the out.rs file, we added there. So we basically just say it as us simulating what the compiler would generate from our macro, right? So the fact that we could see the code we deleted in the out.rs tells you that our macro is working fine. Does that make sense? It's working.
Yes, I guess.
Yeah. So that's the idea. Okay, so I'll just move on. It's like this class is proving to be a short one because I'm actually close to the end of what I'm supposed to do. So system. All right. So this is our $, file. It's not important to us now. That was just for demonstration. So now let's use our second macro, which is the runtime macro. Okay. So this one is going to actually enable us to delete a lot more code, right? So this is going to help us simulate the runtime and the dispatch that is in our main.rs. So we're adding our macro here. Okay. Now I'm supposed to remove the entire implement runtime code block. That's a lot of code, right? Because our macro is supposed to help us implement this runtime, right? In runtime call, where is it? Right, because our macro, similar to our call macro, this runtime macro also implements calling for us, right? And also it implements dispatch just like the other one. And so we also want to change, because looking at our implementations, right? So this is the macro here. Our implementations are using small letters, right? Snake case, not camel case. So we want to change anywhere we use camel case. So snake case. Runtime call balances. Okay. That's what done. And runtime call proof of existence. So let's proof. Let's select this. There are 4 currencies. Okay. So our code compiles. So yeah, this is just demonstration or like the power of macros, right? And so it might not be greatly appreciated because of the small size of the code base. But if you are deleting, if you are not having to write that much code in a larger code base, I mean, I think the value is quite obvious. So, and essentially, we've come to the end of the course that we've been following, actually, the raw state machine course. So I'd just like to get some feedback from you guys. And what do you think about the value of macros? What do you think? Let's hear from Faithful. I think Emmanuel's mic is unmuted. Emmanuel, do you want to say something? Might have to mute Emmanuel. All right, guys. So how was the whole thing been so far? Faithful, the lady, welcome. I don't know why I didn't know why you joined the class. Yeah, Rama, you want to speak?
Yeah, so far, let me say it's an amazing session. Thank you so much for the opportunity. Like at least it's opened my eyes to Rust from let me say advanced level. So it's just a request. During the period of this particular course, we relent, and okay, we started from the, let me say, simplest, then along the line, we added complex things like this macro now. Okay, so it's just from, let me say, from the simple part to the complex one. So if we can just have a class, don't laugh. So I don't know if we can have a class just to do a recap of all we learned, just to explain the code base, walk us through. Okay, since we, like, for the people that attended the class throughout, to be able to understand, but it's just like the class should just be a walkthrough, like okay, from the main.rs to the other parts of the code base. Thank you so much. God bless you.
All right. Yeah, I mean that's a great idea. And I mean I guess if we had discussed this before, I'm sure one of the tutors would have been able to do this during this class. I mean, because we have about an hour more. I want to put Mario on the spot because I feel like he might be in a position to do that. But if he's prepared, but if he's not prepared, we can always set up another class for it.
You guys want to do it now?
Like, if possible, right? I feel since we have an hour, if it's something that can work, that we can do within 30 minutes, just a walkthrough to give them a high level overview of what each file is doing, how they connect together, and that kind of thing. But if you need a bit more time to prepare, fine, we can. Maybe I know Ali wants to do a class tomorrow.
Okay.
So if you need a bit more time to prepare, I understand, and we can do that tomorrow.
Okay. Ali, what classes are you doing tomorrow?
So he wants to add a token vesting palette to the Polkadot SDK.
Okay.
Yeah.
So if you push your current code to the repository and I pull it, so I'll have the complete version, I can do it.
Okay, you can do it right now.
Yeah.
Okay. Let me just do that.
Let's see. No. Git check out. How do you switch branch? Yep.
Okay, I'm actually on the main branch, I think.
Oh yeah, on the main branch. Okay.
Yeah.
I thought let me just quickly commit my stuff. Commit. Online the dispatch. Okay, let's see. Git check out. Yeah. Ooh. Okay, we are here. Yeah. So okay, I think I have. Just let me confirm that I have the. No, I don't have your current version with the macros. I don't have it.
Okay, I just pushed
I think
now.
yeah, to the main
You
or to
can
your branch.
To
you
me.
can push to the main branch and you pull from it my Mauro.
Yeah, I'm trying to pull, but my stuff is saying that. Okay, yeah, I've pulled it now. It's correct.
All
I
right.
pulled it. Okay. So I think I have to share my screen. Let's see. Share my screen. Sorry, guys. I have a bit of cold, so people manage like that.
No problem at all. You were not informed before. No problem.
It's a problem. No problem. It's just so far, right? What we've achieved in the entire course was let me close everything, right? Like it's a state machine, right, for a blockchain that has two main functionalities now, right? So one functionality is working with the balance, and the second functionality is working with proof of existence, right? So, and these functionalities, we call them palettes in the
Okay.
blockchain. Adi, I think you're on mute.
Oh, sorry.
No problem. So the idea is like, okay, so we have these two functionalities, but how do we put them into a coherent system, right? So if you remember, so for instance, in the balance functionality, we have a palette, right? And the idea of the balance palette is that we want to store the account ID of a user and the balance of that user, right? So that we'll know what the user has. For like, obviously, in real world use case, we want to use a database that persists this information, right? So that everybody can access it. But in this application, we're able to use like a B tree because a binary tree, because it's something that allows us to associate a particular key to a particular value. So in this instance, for us, ours is account ID and balance. So if you remember at the start of the course, we used a string for this and we used an integer for this. But as we started adding abstractions to it, we created a type module and we are now able to generalize it over config. So in this palette, one of the things is that we want to be able to initialize like, a new version of the palette. Sorry. And then we should be able to like set the balance of the of a particular user, right? So maybe we want to give tokens and whatever. And when we are setting the balance, we'll be able to take whose balance we are setting and the amount we are setting, and then we manipulate the data inside the binary tree. And then I think the last idea is to be able to get the balance directly from the binary tree, right? So those were like the first three functions, so very basic stuff. So along the line, we then decided to sort of add a functionality. We then decided to add a functionality of. So is it clear so far? Is it clear so far so that I know? Okay. So then we decided to add a balance function, and the idea of the balance function is that we want to be able to send tokens between two users, right, using their balance. So of course, we want to have who is calling this function, that's the person sending the money, who we want to send the amounts to, and what amount we want to send. But at the same time, we want to be sure that the balances are sufficient, right? So you don't want a situation where somebody doesn't have the right amount of money and you are able to send more than what they have, right? So not a situation where you use because integers allow overflow, right? So if somebody has 0 and you try to take 10 for it for integers, either if it's a signed integer, they can become negative, right? And we don't want that. So we want to be able to check that whenever there's not enough fund, we should not be able to carry out the transaction, right? And this allows us to create an error, and then we can now handle it through Rust error handling. But at the same time, the idea is the error should not be something that makes our system fail. So if somebody doesn't have enough money to transfer, we simply don't carry out the operation, but we don't crash the entire system because there are people that have enough money to carry out the transfer. And then, we calculate the new balance and we do the logic for it, we manipulate it, and we return an okay. Now, because of some similarities in the code, right, or because of some genericity in the code, because we were repeating certain things, particularly the call type and the call enum. So one of that particular type of situation is ripe to use macros. So, like you said, macros are really succinct ways to use codes to write code, right? So this call, for example, if we look at the definition of the macro called call, it takes a token stream, right, like 2 token stream, and then it calls a call function inside. And this is the function that sort of generates the the code that we want, right? So this is a function that generates the code that we want, right? So we're not going into detail, but the idea then is that we can now put this macro in front of our implementation, and then this macro does some heavy lifting for us because we expect that thing to be consistent regardless, right? So it allows us to eliminate writing repetitive code, and then allows us to generate that code at compile time, right? So that's one of the palettes that we had. So the second palette that we had was the system palette. So now we have information about individual balances, right? But we're working on a system and we want to know information about the system, right? Because if you have individual user informations, but you don't know how they interact with the system, then your solution is not coherent in a sense, right? So we then built a system palette, and the idea of the system palette is that we should be able to track what block we are currently on, right, to the block number and the nonce, right? So nonce really stands for a value that is used only once. So in this particular instance, nonce is to understand or to have an idea the amount of transaction a user has carried out in the system. So that's why we link it to the user ID and the number, right? So in this example, yeah, so Femi has a nonce of 10. So that means Femi has carried out 10 transactions with our system. We don't know the details of the transactions, but we know, Femi has carried out 10 transactions. So if for some reason we're trying to find out the person that uses our system the most, we can use the nonce for it. But it's really just to sort of see what transaction is like the order of transaction user is carrying out, right? So for us to implement the palette, we of course we initialize it like always, and then we are able to return the block number. So we can read directly the block number from the struct because it's public, but it's bad practice, right? So generally speaking, when you're trying to get data from a struct, it's better to use a function to expose that data as opposed to getting the data directly from the struct itself. It just makes your code more coherent, right? And interestingly, sometimes you can return a reference to it rather than directly manipulating it, right? Then, of course, we wanted a way to increase the block number directly, such that when we are now in a new block, we can increase the block number. And lastly, we wanted a way to increase the nonce, right? So we added this nonce function. So now we had these two palettes, and one of the issues was how do these palettes interact with each other? Because despite them being complementary, there was no initial way for them to interact with each other because they were separate entities at that point. They're separate parts of our program at that point, right? So that's where the runtime comes in, right? So for us, the idea of the runtime was this method of putting everything in the system in one place and then interacting with the entire logic of the system. So the idea of the runtime was to say, okay, we have a system palette and a balance palette. We need to put them in the same place and then interact with these two systems using this one point of entry, which is the runtime. As part of the program, we created some types to make the program more modular, right? The idea is that, if I need to change what account ID represents tomorrow, if I need to change so for instance, content right now is a string, but if I need to change it to a hash, for example, right? Because a lot of times the content is hashed and stored in the blockchain. So if I need to change it to a hash, I can easily change it here and it will propagate around the entire program without me needing to change things elsewhere. So the idea for this is to make the program more maintainable. So it's really more of like a developer experience point of view, right? As opposed to any, concrete functionalities to make the program more maintainable. So we then, do our config, right? So what the runtime then allows us to do is that, so like I said, we compile everything in the same place, right? And because there was a particular function in the runtime that was very, that was sort of not repetitive, sha, but it was like a standard function, right? The dispatch function. And since it's a standard function, we might as well be able to, you know, since it's a standard function, we might, use it for a macro, right? So a macro can generate that code since we know the shape of what that function is going to be and what's going to be done inside the function. So instead of us implementing the function, we can then use the macro to implement the function. So it saves us time for like writing code. So we just simply use the macro. And if tomorrow we create another runtime in another part of the program, since we know the runtime is supposed to have a dispatch function, we can just use the runtime macro instead of writing a new dispatch function, right? So that's where we are. So now that we have had the runtime that consists of our balance palette and our system palette, and we have those nice functionalities about our runtime, right? So how to carry out transfer and everything. So how do we interact with it? So one of the ways was initially we started doing things manually, right? So after we set the Genesis block, we started increasing block number by ourselves, increase the nonce of the person carrying out the transaction and doing the transaction. And if you remember, what we found out was that it's a bit error prone and we could make mistakes. So we wanted a sort of generic way or a sort of like systemic way of creating blocks, right? So that's where the support module comes in, right? So we then defined a structure of what is a block for us, right? And for us, a block simply consists of a header and a collection of extracings, right? So the header for us is a struct also, and the header has a blockchain number and some other metadata about that particular block, right? And the collection of extracings for us is transactions that are going to be carried out in the blockchain, right? So regardless of what type of transaction it's going to be. And for us, what is interesting in transaction is that it has a caller and it has a call, right? So the caller is whoever is calling the who is submitting the transaction, and then the call is what type of transaction it is. The reason why we use call in this particular instance is that as the project expands or as the blockchain expands, there are different types of call that are available to the user, right? So you want to keep it generic so that any call can fit in here, right? So we're basically saying that the call could be any call, right? So after that, we can now see where we use it here. So for us, right? So the extracing, so we can see how we implement it here. That we then create a new block, and the block has a type of a header, so we can specify the header, and then the collection of extracing. So but this particular instance, we can see that this extracing has a caller, which is Alice, and the runtime, and the type of call is balances. So it's calling the balance palette, and it's calling a transfer call within it, right? So we can see how that genericity plays in. In this particular instance, the caller is Alice, and the call in this particular instance is to the proof of existence palette, which we will see soon. And we can now see that. So the point here is that because of how generic call is, we can see that we can use two different calls in the system, and it works, right? So that's the point of all those abstractions we did. And so also, interestingly, right, the use of vec here is a macro, right? So vec is a macro, and if we expand vec under the hood, what vec is something like to create a vector for you, and you do something like vec new, right? And then it will add, I think it will do some push, and then it will push the values inside, right? So we are using a macro here for vec instead of us creating we create a mutable example of vec here. Then we want to put the value inside. We can now say vec dot push. Maybe let me just copy this. We can push this inside the vec, and then we want to do another push, we do a vec.push and put another one inside, right? So instead of us going it this way, what we used here is this macro in this particular instance, and this macro actually expands to become something like this. I don't know the specifics, but it expands to become something like this. Okay, I think we're good so far. Okay, so are we clear so far? Is it clear? Any questions? Any clarifications before we move? Okay. So, so basically, so that whole process that we went through, right, was now setting up the system to become modular and expandable, right? So the system is now well architected. We are using generics. We are using traits. We know how to make calls. Like we know when we make calls under the hood, the actual proper call will be made, right? So that allows our system to be expanded, right? So to show this expandability, we then implemented a proof of existence, right? So the idea in blockchains is that the idea of proof of existence in blockchains is that you are storing a proof in an immutable ledger that shows that something exists, right? So how do we store that proof? Well, in a lot of and that's where like hashing in cryptography comes in, right? So in hashing, when you hash something, it takes a very large amount of data and reduces it to a predetermined length, right? And the idea is that the hashes should not be the same, or typically, like in a good hashing algorithm, they should not be the same, but there are some that have collisions. But the idea is that if something is unique, the hash is unique, right? And a small difference in what you are hashing will lead to a big difference in the hash, right? So, for instance, if you spell my name, right, Ogenemara, you hash it, it should give you a hash. And every single time you spell my name correctly and you hash it, it should give you that same hash. But if you change a word in my name and you hash it, it should give you a completely different hash. In fact, if you change the case, right? So if in the first hash you use small letter O in the beginning, and in the second hash you use capital letter O in the beginning, they should give you two different hash, right? So the idea is that you can now use this to show your claim, right? So let's say you are trying to claim that you have a particular certificate, right? And that certificate is consistent. When you hash the certificate and store it in the blockchain, if someone comes and someone wants to confirm that claim, all they have to do is hash that same certificate the way using the same algorithm you used. And they will now see that your hash and the hash they got from that their hashing algorithm is the same. Right. So that's like a basic level of how the proof of claim really works. So is it clear so far? Okay. Yeah. So thank you. So with that in mind, we then create a palette that has content, right? So content is what we want to claim, that what we want to prove exists, and account ID is whoever is creating that claim, right? And account ID is like a user in the system. So like with the balance and with the system, we use a binary tree map to set it up, right? And then we obviously initialize it. And then we can get claim. So the idea of get claim is that if somebody says they have a claim in the system, we can pass the contents into the system and see who claims that content, right? So we can pass the hash into the system and see who has that hash or who has stored that hash in the system. So with the previous, so we then have like two other functions, which is called create claim and revoke claim. So the idea of create claim is that somebody is saying that somebody is claiming a particular piece of content, and then revoke claim is that somebody is saying I no longer claim this particular piece of content, right? And it also uses dispatch calls, right? So there are very specific calls around it. So in the previous implementation, we had like enums to show which call, and then we match on the enums, and then we in the dispatch block we match on the enums, and then we say that, well, if we match on this enum, if it's create claim, we call this create claim function. If it's revoke claim, we call the revoke claim function. But since that process is a bit, when I say not generic, but since it's consistent, it's something that can be written into the call macro, right? So that's why we then use the call macro to do the code generation instead of us writing the code. So it takes away the amount of code we write. And the idea is that since it's an SDK, any other person interacting with this SDK can use this call macro, and all our systems will be consistent because the underlying calls are implemented by the macro instead of us. So it reduces chances of implementation error. So with that in mind, we have finished the proof of existence palette. And since we spent a lot of time setting up our runtime, what happens now is that it's as easy as just adding a field called proof of existence and then importing the proof of existence palette into it, right? And since the macro does the heavy lifting with runtime, we really don't need to write any new dispatch functionality for it because it's happening under the hood. So if we want to add a new functionality to our runtime, so long as it is consistent with how we've done it before, we don't need to write a new dispatch block for it, right? And so I remember the main file used to contain a lot of code before, but now it's just very simplified, and then the macro expands everything in during compile time, and we get the same software we had as if we wrote it by ourselves, but we don't write. And we see how the claim is used. The proof of existence is, they want to get who has this claim, and they want to so Alice wants to create a claim hello world, and Bob wants to create a claim hello world. I think Bob's own should fail because Alice already owns that particular claim. And we can see that they want to revoke it. Alice wants to revoke the claim, and Bob wants to create the claim. So Bob's own should pass now. So that's really it. If you have any other questions, like any part that has not been clear so far, or any other thing that you want me to explain for you that you came across during the course. Any questions, comments? Was it clear? At the very least, was it clear? Okay.
Yeah, it was clear.
Okay.
Okay. I also like to add Faithful, not the lady now, the guy, because I think when Rama said we should go over it again, I think you signaled that yes, you want us to do that. So was it also helpful to you? I don't know if Faithful can hear.
Hello, can you hear me?
Yeah, I can hear you.
Okay.
Yes, it's good. So, but I will need to still go over the code to better understand it. And it was a very helpful.
Okay. All right, that's great. And the video will also be made available. So in case you need the video.
All right.
Yeah. So who wanted to speak? I think it was the lady, Faithful, but she has left the call, probably a network. Okay, I would. Yeah, so the journey for learning Rust as it relates to Polkadot does not end here. So this is a phase. One phase has ended. To cement this phase, Ali will be having a short class tomorrow, just to get people to interact with the actual Polkadot SDK. And we also have some things in the pipeline, right, that we are trying to work out to keep our developers engaged. Okay, we'll reveal them very, very soon. We will not waste time on them. So Yes, and what I would encourage people to do is, just challenge yourself a bit, right, with the concepts you've learned already. It doesn't matter if you make mistakes or fail, you get, but I think that challenging, so maybe short, small exercises, or maybe even going to that raw state machine course and trying to, even it could be as simple as going to the very beginning and trying to do something yourself without looking at the solution and see if you can get it right. And then look at the solution to compare what you did to what is actually right, that kind of stuff. I've been seeing lots of buzz around Rust. I don't know, but it seems lots of people like the language. I won't say I won't rush and say I like the language just yet. But I mean, it works, it does what it's supposed to do, and it's very powerful. And I believe it is also a very valuable skill to have, right? To be able to code Rust. I mean, for example, in the blockchain space, virtually every blockchain uses Rust. So this means that you are very versatile, right? This means you are very versatile, and this probably means you always have something to do in terms of job, right? And to add to that, I think the language is also considered to have a high barrier of entry. I don't know whether it really does. Maybe in terms of system specs it does, but in terms of learning, I think once you have a little bit of aptitude for programming, you should be able to grasp it. But I think some people think it's difficult. So what that means is the field is probably not crowded, right? And so that's more opportunity for you. Okay, so yeah. So one last thing, we have a feedback form here. I would just like you to take, it should not take you more than 2 minutes to fill. You can just fill it before we leave the call. Oh, Rashid said he could not hear. Okay. So I want everyone to fill it while we're on the call. Let me stop the recording. Stop recording.